In this session, we will learn about the concepts on electromagnetic waves and their properties, dispersion, photometry and optical instruments. First, let us see what is meant by electromagnetic waves. Electromagnetic waves are waves which can travel in vacuum. They don't need material medium. They don't need material medium like mechanical waves. So the general name given for them is electromagnetic waves or EM waves. In an EM wave, there is a vibrating magnetic field and a vibrating electric field perpendicular to each other. The electric and magnetic vectors are represented by E naught sin omega t minus kx for propagation along x-axis, B equal to B naught sin omega t minus kx. This represents a EM wave traveling along positive x direction. Positive x direction. In general, if the electric vibration is along the x-axis and magnetic vibration along y-axis, the propagation of the wave will be along z-axis. So in an electromagnetic wave, there is an electric vibrating field and a magnetic field vibrating perpendicular to each other, and the direction of propagation is mutually perpendicular to the plane containing, mutually perpendicular to this field. That means it is a perpendicular to the plane containing the electric and magnetic vectors. Okay. And the direction of the energy flow, electromagnetic waves carries energy, it transfers energy from the source to the receiver without the help of any intervening medium. The energy vector is called as the Poynting vector, energy flow. Poynting vector. It is represented by S, and S is given by half E cross H, where H is the magnetic intensity. In terms of magnetic induction, it will be given as 1 by mu naught E cross B, because we know B equal to mu naught H. So B is magnetic induction, H is intensity. H is intensity, magnetic intensity or intensity of the magnetic field. Okay. So the modulus of this Poynting vector equal to E naught H naught or E naught B naught by mu. The speed of light is given by E naught by B naught. So in an electromagnetic wave, there is a vibrating electric vector and a vibrating magnetic vector, and the energy flows or the wave moves perpendicular to the plane containing these two vectors. Energy is carried by the wave. The energy flow vector is called as a Poynting vector, and it is given by S equal to E cross H, where E represents the electric field and H is the intensity of the magnetic field. In terms of magnetic induction, you will get a proportionality constant, that is mu naught. Okay. Now, what are the properties of this electromagnetic vector, electromagnetic waves? Electromagnetic waves are transverse in nature, only transverse waves. This is proved by polarization. Electromagnetic waves can be polarized, which means they are transverse in nature. They can travel through vacuum. All of them travel through vacuum with a speed c, which is speed of light 3 into 10 power 8 meters per second. We can classify these electromagnetic waves in the following way, and it is called as the electromagnetic spectrum. It is called as the electromagnetic spectrum. So this is the visible region which is bounded by violet on one side and red on other side. This is called as the infrared region, and this is called as the ultraviolet region. And in the red side, in the red region, first you have the heat or thermal radiation, then you have the microwaves, then you have the radio waves. If you take here increasing wavelength, so the wavelength of the wave increases from this extreme to this extreme, representing ultraviolet waves are having very short wavelengths. Okay. The wavelength of light violet is about 4000 angstrom, and this is about 6600 angstrom. And here you have X-rays and gamma rays. The relation between wavelength and frequency is given as C equal to nu lambda, where lambda is the wavelength and nu is the frequency.